Hey everybody, this is Alex Merced, head of DevRel at Dremio, and today we're talking about streaming to Apache Iceberg tables. So most of this talk is going to be a little more just talking sort of like at a high level of like what is Apache Iceberg, what is the data lakehouse, one, why do we care about the data lakehouse, why do we want to stream into the data lakehouse, and some of the considerations that are kind of unique when you're streaming into a data lakehouse. But before, let me introduce myself. Again, my name is Alex Merced, head of DevRel at Dremio. I've gotten to, as mentioned, I got to write Apache Iceberg, the definitive guide. I've also gotten to write Polaris, the definitive guide. And my newest work is architecting a data lakehouse. And then also got to do a collaboration with PuppyGraph, Fivetran, and a few other companies on a written work that will be released tomorrow. So look for that announcement. But yeah, as far as like Apache Iceberg and Apache Polaris, the definitive guides, those can be downloaded for free. This QR code, you also have those QR codes in the cards on your desk. So there you can get those books for free whenever you feel like it. But only at this event can you enter the raffle to win a free copy of Architecting an Iceberg Lakehouse. That book is not available for free. So entering the raffle will give you the opportunity to get a free copy. Essentially, basically, probably Thursday, I'll go through the, look at the submissions and then do a random drawing. But for this one, looks like for this event, you guys will have a good chance if you enter, because this looks like at best 1 out of 5. So God, chances are good. So sign up. Okay. But let's start off by talking about what is a data lakehouse. I'll put that up there for like another few seconds. Sorry, phone go up. Okay. So let's talk about what is a data lakehouse. And to understand really what a data lakehouse is, we need to think about what's come in the past. So traditional data systems. So traditionally we would work with databases and data warehouses. And we love databases and data warehouses, okay? They do a lot for us. They're essentially these nice integrated systems that do lots of things so we can just work with our data. What kind of things do they do for us? They store our data, okay? When I put a data in Postgres, I don't know how that data is stored necessarily. I just know that it is being stored by the Postgres system and it's gonna manage that storage. How does it know which data is part of which table? But it works, okay? I can go into Postgres, I can go to Snowflake, I can go into Redshift, and it knows which data belongs to which tables, regardless of how it's stored. These are just things that are abstracted away from me, okay? Giving me a really nice experience working with my data. How does it know how many tables I have? Well, there's a catalog. So built into the system is a catalog that tracks all these tables, who has access to them, all these good things, okay? And then there's the processing layer that's going to parse my SQL queries, is going to then turn those into execution plans and then go execute those queries. All of this is just kind of wrapped up in one system. So when I use something like a Postgres, I just run Postgres, I create tables, I run SQL against it, and I don't have to think about all these layers. Okay, whether I'm talking about doing like transactional row-based data in a transactional system like Postgres, or I'm talking about like systems like Snowflake, Redshift, et cetera, that are more analytical in nature, where the data is more than likely going to be stored in a columnar format. But regardless, all these things are abstracted away. And that's great, except for one big catch. Every system does it differently. So the problem is, if I have a situation like this, where I'm a big company, okay, so after a while, basically every department kind of needs to work much more autonomously. So you end up in kind of, how do you manage a data platform as you kind of hit those enterprise levels? Well, you fall into one of sort of two sort of buckets. You're either going to have like a central data team that's going to manage a platform that everyone has to use, but then that central team can become a bottleneck because everyone's putting in requests saying, okay, hey, I need to change this, I need to get this. That takes time. Two, or you have each department create their own data platform. But now let's say you have sales using Redshift, finance using Snowflake, marketing using BigQuery. All of that data is being stored in the format for that system. And now if sales wants marketing's data, and they're going to have to do ETL from Redshift to BigQuery. And if marketing wants finance's data, they're going to have to do ETL from Snowflake to BigQuery. So you end up having all this additional ETL and data movement that happens because everyone's using different fragmented systems. So that basically, while databases and data warehouses are great, because they all kind of do things slightly differently, it creates this world where we have a lot of data replication, which comes with costs, more pipelines, which can break, and all the data quality issues and consistency issues that come with it. So then there's another paradigm. There's the paradigm of the data lake, where, okay, now we're just storing data as files. So instead of having this integrated database or data warehouse system that has all these different layers just wrapped up into one, I have a data lake and it's storage. And I'm storing my data in Parquet files, maybe storing unstructured data like images and video, text files for like emails, logs, stuff like that. All this data just being stored as files. Wonderful. So why don't I just run analytics right directly off my storage? You could. This was like sort of like the innovations with like Hadoop and Hive, where I could run analytics, but it wasn't quite a database. It wasn't quite a data warehouse. I didn't have ACID transactions. I didn't have, there was a lot of niceties you'd be used to in a database or data warehouse you just didn't have. So we start getting into what is a data lakehouse. So again, we have data lakes, and data lakes allow you to have storage. So I have somewhere to store my data. And there are tools I can use to query the data on my data lake. Tools like Trino, AWS Athena, Dremio are all engines that are built for reaching to your data lake, querying those Parquet files, etc. But again, it doesn't quite feel like a data warehouse. When I think about it, if I go back to where we were talking about database and data warehouses, there were two things in the middle there that we don't have. Okay, if I could figure those two things out, then suddenly I have a system that does work like a database or a data warehouse. And this is where we get to the data lakehouse. So we got the data in storage. We got tools that can go operate on that data, but what we're missing is a way to recognize which Parquet files belong to which tables, a table format. This is where Apache Iceberg, Delta Lake comes in, saying, okay, it's not just a big sea of Parquet files that I have to understand what they belong to, which data sets they belong to. The system knows these 1,000 Parquet files are part of this table. This 1,000 Parquet files are part of this table, has the stats to scan them intelligently, overall operate like a database or data warehouse. But I also need to track those tables. I need a way to know, hey, which tables exist and who has access to them. That's a catalog. So when we think about things like Polaris catalog, Unity catalog, Nessie, that's their job. They know which tables exist. They know when you pass your credentials to access the catalog, who has access to which tables, so that way you can actually govern them in the same way you would govern your tables in your database or data warehouse. So now I have all the layers intact. My data lake is now behaving much more like a data warehouse. I have a data lakehouse. So ideal world, the world that I end up in is a world that looks like this, where I have my data sources, I ingest them, and that data is going to be persisted as Parquet files, data files, that will then be grouped into tables using metadata, the table format, and then tracked and governed via a catalog. But the cool thing is, now every team can use whatever tool they like. So if one team is using Dremio to run their analytics, they can go talk to that data. Someone else is using Snowflake, they can go talk to that data. Okay, whatever tool you want to use, you can use, and you no longer have this fragmentation between departments. You don't have to force every department to use the same set of tools, but you don't necessarily have to end up in a world where you're doing all this redundant ETL between all your departments either. So, a very sort of ideal world. Okay? Of course, the devil's always in the details and actually like getting all those pieces nice and set up. So you end up in a world like this where now everyone just ETLs their data into the lakehouse using whatever tools they like, and everybody can access each other's data as long as they've been given access in the catalog. Okay, so it becomes much more about how do you get the data into the lakehouse, and then no more having to move data after that, which is much simpler. Okay. Cool. And then, again, a lot of that was kind of very much covered in the keynote, where it was just basically you can use like Ursa to just kind of get the data into the lakehouse, and then everyone can just start running analytics right off of that. Okay, but traditionally, like when you're talking about streaming into Iceberg or really streaming into anything, what happens? You have your streams. So oftentimes you're talking about topics that are hanging out in Kafka clusters. Okay, so those sit in a Kafka topic. And then there's different ways you could, at least in an OSS way, land that data back into your destination, in this case, an Iceberg table. So that could be a Kafka Connect. So once upon a time, there was a company called Tabular, which was acquired by Databricks, but they had built a Kafka Connect connector. And then basically what that does is now if you have a Kafka Connect cluster, as data hits a topic, that Kafka Connect job will then land that data into Iceberg tables. Okay? So that's one approach, and that was probably like the earliest approach. That and like using Flink. So basically, Flink has a Apache Iceberg library, so you can target landing data into Iceberg tables. We're using some sort of commercial offering, okay? And this year has been an explosive year as far as like Iceberg and streaming, okay? So many different new interesting ways. Like probably one of the biggest things nowadays is like skipping the first two instead of saying, okay, hey, let's have the topic and then land the data into Iceberg tables, having the topic be an Iceberg table in a sense, okay, where basically there's different ways it's done, but the idea is that basically you end up persisting the data directly into an Iceberg table from the topic. And that's sort of a big thing that I'm seeing in a lot of offerings, which is really, really cool. Okay, but bottom line is you land it into your data lakehouse, and then you can use whatever preferred tool you want to run analytics from there, whether that is a Dremio or an Athena or Databricks or Snowflake, whatever system you want can then read that data from that lakehouse. All you have to do is connect to the catalog. The catalog becomes the arbiter of how everybody discovers those tables. Okay? So, and then that feeds all your BI, AI, ML apps, data apps and reports. So, bottom line is I'm not going to spend too much time because probably a lot of this stuff you're going to be pretty familiar with, like what the Kafka Connect is and Apache Flink is and all this stuff. Bottom line is like Kafka Connect, and then I have articles where I've written hands-on exercises where you can actually like spin up a cluster on your laptop and land data as Iceberg tables, so see this firsthand. So this is a QR code if you want to read the blog that I have on Kafka Connect and do that exercise on your laptop. So I'll leave that up there for a moment if anyone wants to scan it or just take a quick picture of it to scan later. There'll be lots of QR codes. I'm a QR code kind of guy. And just as a reminder for those who got in a few minutes after I started, just so you know, on the seats, there's a sticker and then there's a card. The card has a QR code, so you can download both those books for free. So that way you can get Apache Iceberg, the definitive guide, and Apache Polaris, the definitive guide for free. Cool, cool, cool. And then I'll put the raffle slide back up on a little bit later. Okay? But again, Kafka Connect is essentially a framework for basically moving your data from a Kafka topic into some sort of destination, which could be Parquet files, could be a table format like Iceberg or Delta, etc. So that's pretty straightforward. Again, you're going to the same thing as you see with most streaming stuff. There's your data sources, and then there's your connectors or sinks where you land the data into. Okay, the benefit of these systems is more like their fault tolerance, the fact that they're distributed, and they're able to kind of keep track of where they left off. Okay, again, won't beat the point about this because this is going to be probably stuff that we're all pretty familiar with. But essentially, what happens is that specifically in the Iceberg Kafka Connect sync, what happens is you have generally a control topic and a source topic. So like the source topic is where the actual data is coming from. And then the control topic is kind of how it checkpoints, how it tracks, okay, here's how much we've completed of the stream, so that way it doesn't reprocess the same data. Okay, and then essentially what it's going to do is going to write data to your storage, start writing Parquet files and tracking which Parquet files have been written but not committed. And then periodically will then actually commit the transaction to your catalog. So like a little background on like how Iceberg works is that, and how it achieves ACID guarantees, is that there's sort of three layers of metadata. There's something called the metadata file, which is like the file that says, this is the table schema, this is where the table's partitioning, like basically describes the table. Now, every time you change a table, you create a table, you add records, you delete records, you create a new one of these metadata files. Okay, and that new metadata file is going to have not just have the newest snapshot, the newest version of the table, and all the previous ones. So the way the catalog typically works is the catalog is just basically a key value, sales table, and then the address of the latest metadata file for that table. So that way I can locate the right one. Because if you've done 1,000 transactions, there's going to be 1,000 metadata files sitting there in your storage, okay, of these metadata.jsons. How do I know which is the right one? The catalog is the arbiter of truth. So essentially, if the catalog hasn't been updated, the transaction hasn't happened to the eyes of people who are querying those Iceberg tables. So yes, Parquet files may be being written to storage, but until a metadata.json is created, and then the catalog is told going forward, this table points to this metadata.json, then the transaction is actually committed, and any following queries will actually hit that metadata.json. Okay, so essentially, there is like a little bit of latency depending on what settings you set for the connector. Okay, so this is like an example of some JSON used to set up a job using the connector. Okay, this is from a while ago because so you can see like the jar is a tabular jar. Since then, the jar has been contributed to the Apache Iceberg project. So now it would be like org.apache kind of thing. But essentially, that's how that would work. Okay, Apache Flink. Okay, again, I have a blog where, again, you can do a setup. This has like the Docker Compose setup, all that stuff, so you can do it all on your laptop. Basically run Flink, see the ingestion of an Iceberg tables, Basically, the way I usually do all these tutorials is I'll set up the tool, so Kafka Connect, Flink, whatever. I'll set up like a min.io storage, so that way you have somewhere to actually store the Iceberg tables. And then I'll set up like a nested catalog, so you have an Iceberg catalog. And it's all running off your laptop, and you can see sort of how the whole process works. I try to keep them as simple and easy as possible to kind of just really see how you get from point A to point B. Okay, but Flink is a stream processing framework in the same way like Spark does like batching and micro batching. Flink is focused on stream processing. Okay, and again, generally with stream processing systems, the great thing about them is fault tolerance. Okay, they're going to be doing things like checkpointing to track sort of where you're at in processing things, have ways to sort of fall back. But bottom line, this is all very focused on streaming. Okay, again, okay, so then we got. But basically, again, with like any kind of cluster-oriented system, whether it's Flink or Kafka Connect, you're going to have jobs and tasks. Okay. Now, in the Flink world, once you actually have the Iceberg jar loaded into your Flink cluster, essentially the way you would start interacting is you have two choices. You can either use the table API, so that way you can just use SQL when you're writing your Flink. So in this case, the first thing you have to do is you create a catalog. Because again, everything in Iceberg operates around the catalog. Whether it's Flink, whether it's Spark, whether it's Kafka Connect, it needs to know when this transaction is done, who am I updating about the metadata.json. So first thing I do is I configure my catalog. So here's an example of me configuring a catalog, specifically a nested catalog. Okay, and then here, in the example that I do in the blog, what I do is I create like a data frame, and then I turn it into a temporary table. So just a quickly example. So what I'm doing here is I'm just creating a temporary table out of a data frame, and then I'm just going to copy that data frame into an Iceberg table. So I do insert and select db.table select from my data stream. So I'm just injecting those records into the Iceberg table. So as you saw in the previous slide, there I'm creating a catalog. Theoretically, the table is either already created or I create a table, and then I can insert into that table. Okay, but whether you're using any of these systems, okay, or using, again, commercial offerings, like a lot of the cool stuff you saw during the keynote, which was really cool, actually. That was actually really good. The thing is that once the data is there, the story's not over yet. Like when I'm using, again, database or data warehouse systems, one of the things I mentioned is that they manage storage. Okay, so that means I'm not thinking about how the actual data is stored. I'm not thinking about how it's rewritten to keep Snowflake, Postgres, whatnot running nice and smooth. It figures all that stuff internally. But there is no big system when it comes to a data lakehouse. There's no big system that's managing this for you. All the pieces are separate. Your table format is separate from your catalog, which is separate from your storage, which is separate from all these pieces are modular. That's the beauty of it, because you can build a system that's perfect for you without locking yourself out of tools. But it also means there's this extra layer of thought. There's some thought about how do I manage the storage of my data. And this is particularly important when it comes to streaming, because oftentimes with streaming, you might be streaming in small bits of data at a time, and that data has to be persisted to Parquet files. And now you have a lot of Parquet files with maybe a handful of records, or not the ideal number of records, okay, depending on how you set up your streaming jobs, okay? And that's gonna hurt performance over time because you're reading more files, okay? So there's gonna be much more I/O operations per transaction. So then you need to have some sort of strategy of how I'm gonna rewrite those files, okay, as part of managing your stream, okay? And the biggest issue is gonna be this compaction deal, okay? So essentially, I might have files like here. I have 4 256 meg files. So that means, let's assume that's one partition of the table, okay, any query is going to have to open up and read 4 files. I could then compact that into one large gigabyte file, and now I could run the same query, and it's only going to open up one file, which is going to speed up that query a bit, okay? So the question is, how do I do this? Now, built into the Iceberg world, okay, there are a bunch of Spark procedures, okay, but one thing you're starting to see is like this is one of the bigger, like I would say the 2 big things in Iceberg this year have been streaming and storage management. Like those are the 2 things, the 2 reoccurring themes this year. So like a lot of I would say new offerings you're seeing from vendors either come from, hey, we're going to help you stream better into Iceberg, or we're going to help you manage the storage. So you're starting to see companies like Dremio. We have our own offering as far as managing this goes. There's a new company called Rift that just that's their thing, that managing storage. and sometimes it's paired with the streaming solution as well. There's a lot of different ways you're starting to see sort of this becoming sort of vendorized, which is important because this is not something you most of the time probably want to have to manage on your own and have to kind of handle. But the question is, especially with streaming, how often should I compact? Because again, data's coming in a whole lot, and if I wait to like the end of it's not like batch where I can control like the size of the data that's coming in a little bit better. So the data files might be more optimally written up front, so I don't have to run compaction as often. With streaming, I'm going to want to write it very aggressively. Usually the way I've thought about this is I think about sort of how the table is structured. So for example, if I have a table that's partitioned based on time, so let's say I'm partitioning the table based on hour, then theoretically, if I partition, you can actually tailor these jobs to only partition a specific portion of the data, because it would take forever to rewrite the whole table, especially as the table gets bigger and bigger and bigger. So some strategies are like, okay, hey, at the end of the hour, let me do a job that's just going to rewrite the partition for that 1 hour. Because in that case, if that partition is just that hour, then once I rewrite that hour, it's optimally written. Okay, I never need to touch it again. Okay, but what if so much data is coming in an hour and so many files are being written within the hour that even though you still want to rewrite that hour partition, you still might need some additional maintenance in the meantime to keep up query performance. And this is where starting like actually show you how these like jobs look like. So in Spark, the procedure is called rewrite data files. So you see here, like I have a catalog called Nessie in this case. And every catalog, you have these functions built into the Spark Iceberg libraries. So I'm saying, hey, Nessie, for this catalog, I'm taking a look at the system procedures. I want to use the rewrite data files procedure. Here, and then I'm just saying, hey, this is the table that I'm targeting. Okay, this is a plain vanilla one. This is going to rewrite the whole table. So it's going to evaluate every file to see if it should be compacted or rewritten into a bigger file or not. Again, depending on the table, that might take a little longer than you need, especially in a streaming situation where you don't want these jobs to go too long so they don't collide with your writes. Okay, so in that case, you're starting to think, okay, how can I make a much more narrow job that won't cause any issues with the data that's coming in? So you do have different different settings. Now these settings won't necessarily save you time, but let me just talk about these settings first. So you'll see there's a setting called strategy. Now, when by default, the way this is going to work is going to do bin pack. So essentially what it's just going to do is just crunch the data into bigger files. Okay, it's going to be very non-discriminate about that and just say, okay, hey, I got 4 256 meg files, let me make 1 gig file. When I do a sort strategy, then it's going to co-locate the data. So in this case, if I know queries are coming in based on a particular key, I can say, hey, you know what, when you run this job, make sure that sort the data first and then write it back to the new files. So that way the data is more well clustered across the values that are typically queried, which is very useful if you know what those query patterns are. Okay? If you don't know what those query patterns are, then preemptively do clustering might not necessarily be a good idea either, because it will be a longer job, because then it has to do all that sorting before it starts rewriting the files versus just grouping files and rewriting them. Okay? Cool. Okay, and then on top of that, you can do what's called a z-order. So you can also do a z-order sort where you're basically weighting multiple columns. A good visual I always kind of imagine when it comes to z-order is I think of like a square with like 4 quadrants. And I think, okay, imagine that this axis here is going to be age, and this axis here is going to be height. So I'll say, okay, the first quadrant is going to represent people between ages 1 through 50, basically 1 to 5 feet in height. So that's one quadrant. So all those files are going to get written. Everywhere both those things are true will be written to these data files, and same thing for each quadrant. So you're essentially kind of weighting both measures equally and creating this sort of 4 blocks of data files in a sense. It also will, if you know that your queries are oftentimes height and age, then that's a great thing to do. If you're not querying that way, then you wouldn't want to do this, because again, it's going to add more work to the job. Now here's where you can start saving time. Okay, so you can start seeing like there's settings here like minimum input files, max concurrent file group rewrites. These can be tweaked to make sure that less files are in consideration. There's other ones that are like minimum input file size. So in this case, if you're talking about streaming and you just want to do some really quick optimization jobs as you go, one thing you can do is you can change the minimum input file size so that way only the smallest files get considered. So that way, if you have a file that's like maybe not the ideal size, but it's most of the way there, maybe you wait for like the hourly job to compact that one. but maybe you have like smaller jobs throughout the hour that'll like get all like the 1 or 2 meg files and build them up into something a little bit bigger. So the idea is like to tweak the job so that way it gets executed a little faster, but still provides you a little sort of incremental boost while you wait for the next bigger job that might have more time to execute. So there's a lot of different settings like that. Like again, minimum number of files to be considered. So that way, like, hey, if there's only 3 files worth compacting, and I have like a minimum input files of 5, it just won't write. So it'll just move on. So this way, I'm not necessarily doing work unless I feel like I really need to do the work. Especially again, when you're thinking about those jobs you need to do really fast midstream. Okay, versus like doing larger, longer running jobs during times where you're just like no data coming in. Cool. And again, also you can do is you can filter which data is being impacted. So again, you can target a partition. In this case, I'm saying, hey, I will only want to compact the data where the department equals engineering. Maybe that particular table is partitioned on that field. And what I can do is have a cycle where I'm partitioning data on a cycle. So I'll say I'll do this partition at this point, this partition at this point. So that way there's a rotation, and that way those jobs don't take as long. Again, it depends on how you're streaming data as partition. I imagine you're probably going to see more like, I'd be doing more like, hey, where timestamp is this, or in this range, or something like that. But again, this gives you the ability to sort of strategically think how often and which parts of your data should be compacted to make sure that it interrupts that data that's coming in as minimal as possible. Okay? That's just the same thing, but in Dremio. So it's like, in Dremio, it's just called optimize. So again, different platforms that offer these procedures will offer them with sometimes different syntax, but it's the same idea. So you can see the minimum max file size. Again, those are all settings available to you in both to help tweak sort of what the job actually does, to help target sort of the length of the job. Okay? So, and again, basically making the same point where we can target a particular partition. Cool. Now, before we get into questions, what I want to do is just kind of summarize some of the stuff we've talked about. So again, 1, lakehouses. Lakehouses are important because it does a couple different things. One, it's going to minimize the amount of data movement and the friction of sharing data between different departments and teams, and not also across organizations. Because basically, if the data is in a uniform format, not only does data not have to move within my company, but data doesn't have to move between companies. Someone can just give me credentials to a catalog, and now they can share data with me. And this allows us to sort of have more canonical copies of the data. But also allows us to use a much wider variety of tools. Okay, because everyone's using a standard format, there's going to be many more tools that can provide you the services you need to ingest and run analytics on that format, which gives you more flexibility. As new tools come out, you can use them. Okay, you're not having to like do big data migrations to use the coolest, hottest things. And then also just reduces cost. Okay, again, object storage is going to be cheaper. And then you get all the benefits of that. And then again, it's just going to be more flexible. But you have to, get the data into the format, which is where like a lot of the streaming solutions you're hearing talked about throughout the day today are there to help you get the data into the format. But then you need to manage the storage of the data in the format as you do that. And that's where a lot of the compaction stuff in the second half of the presentation goes. So again, you can do it with some of the OSS things that I've talked about, like Flink, Kafka Connect. Again, you can use things like Ursa and a lot of the things that you saw again today during the keynote. There's lots of options, and that's the beauty of the Lakehouse. With that, I also just want to make sure, for those who missed this slide earlier, that if you want to win a free copy of Architecting an Apache Iceberg Lakehouse, my upcoming book number 3, here's a QR code for that. So I will probably Thursday do the drawing, and then you'll get a coupon code. The winner will get a coupon code with so they can get the book for free. Okay. Other aside from that, there's again stickers on the tables and the cards where you can get the other books for free and find a lot of other cool resources like demo videos, a lot of the blogs that I talked about here, and some videos where I'll walk through a bunch of other stuff. If you don't already follow me on LinkedIn, do that as well. I do talk a lot. So hopefully you can enjoy me talking some more. But with that, I'll open it up to any kind of questions, hopes, fears, dreams anyone has. Go for it.
So if you create any sort of roll-ups on the Lakehouse to display the UI and stuff like that, does it still need a traditional database, or does the Lakehouse?
It depends how you do it. Like different analytical tools are going to have their own different tools to kind of create like roll-ups, aggregations, things like that. Like I'm not in depth with every analytics tool. I am pretty knowledgeable about how Dremio would handle this particular problem, so I'll speak to that angle. But again, different tools are going to do it differently. So Dremio has a specific solution for this problem. We have a feature called reflections. So before Iceberg was like what it is now, one of the things that Dremio thought about, because we were definitely one of the earliest to sort of really building Iceberg into the product. So the first iteration of Iceberg into the product was not necessarily for people to have Iceberg tables, but for us to use Iceberg tables under the hood to accelerate your queries. So you would have a table like in Postgres that you wanted to do, let's say, a rollup or aggregation on, and you would create a reflection in the Dremio UI. And what that would do is pre-calculate all those aggregations and save them as an Iceberg table on your data lake. And then Dremio would substitute that out at query time, which had all sorts of cool benefits. But the point is like, okay, hey, it's an interesting use of Iceberg. Now that people are natively using Iceberg, this opens up a lot of sort of new possibilities. So one of the things that we've done in the latest iteration is that if you're natively using Iceberg, we can take a look at your query patterns and identify when those types of materializations need to be created, and we'll create those reflections for you. So that way you'll just notice that the performance improves on your BI dashboards or your AI agent overnight because we're monitoring that. Other people will do that through materialized views. Like a lot of people have like dynamic materialized views, which are similar. I mean, a little bit, the big difference is like the Dremio reflections are a little bit more dynamic in the sense that it's not just saying, hey, this materialization belongs to this view or table. It's like we know it's associated there, but we can calculate whether it can be used for other queries. So you get much more reusability behind the scenes. So there are some technical differences. How am I doing on time? Good. Okay, perfect. Okay, cool. But does that kind of answer the question? But again, depends on the tool you're using. So I would take a look at whatever you're doing to actually do that last mile analytics and see what kind of acceleration tools they have. They might have a caching layer of some sort, materialized views, whatnot. But you would still do something, but it may not necessarily mean you have to deploy another database. Usually your analytics tool will have some sort of acceleration feature built into it. Cool. Yep. Yep. I think in the early days, that was one of the reasons why I think Iceberg has Avro support, because for that very reason. I think with some of the advancements that a lot of these like streaming platforms are doing, like the need to do that is a lot less, because they're handling a lot of that. Where do you go fetch the data from short run quicker? Where they basically may have some data stored in Iceberg, but then some stuff still sitting in memory, and then when you hit the cluster, is going to grab the data, the most recent data from memory versus hitting those Parquet files on storage. It depends on sort of how you're doing it. Like if I were doing end to end, and even nowadays, again, even a lot of the OSS options have kind of innovated enough where this is a lot less. So that's a viable strategy. I just don't know if it's as necessary as it used to be, just because of a lot of the way these platforms have improved their use of Apache Iceberg and how they handle those things. But the way I would think about it is I would not reach for that first. I would reach for just going straight, starting with Parquet to begin with, and see what the latency is. And if you need to speed it up from there, then I would start with Avro and then compact into Parquet. But I wouldn't start there. Any other questions? Hopes, fears, dreams? Okay. Well, let me ask you guys one more favor, just because I got to, prove to everyone at work that I exist and that I was here. Let me just grab a quick picture with y'all.
Do you want me to take it for you?
No, it's perfect. Selfies are the thing. Anyone who follows me on LinkedIn knows selfies are very much a thing on my LinkedIn stream. Okay, but with that, I'm here. If you have questions, if you want a Iceberg necklace, I have Iceberg necklaces, a limited supply. And otherwise, thank you guys for joining me here today. Again, do scan those QR codes. I'll be around all day if you have any other questions. And do enjoy your day at Data Streaming Summit. And make sure to check out all the panels and all the other cool breakouts coming out for the rest of the day.